So, when you hear the word statistics, what comes to mind? For a lot of people, it's this: intimidating, complicated math class. Well, get ready to change that, because today we're going to see that statistics isn't some kind of barrier. It's actually a powerful lens for making sense of the world. Let's pull back the curtain and see how it all really works.
I just love this quote from Professor David Hand. It completely nails what the field is all about now. It's not about memorizing a bunch of formulas, right? It's about the thrill of discovery, the power to make genuinely better decisions, and yeah, the fun of finding stories hidden right there in the data. Okay, so let's get grounded with the official definition. At its heart, statistics is a process. It's a systematic way we can take this flood of information and turn it into clear, actionable knowledge. And that process, that's exactly what we're going to walk through.
To guide us on this journey, we're going to use a framework that researchers and analysts rely on every single day. It's called the PPDA cycle, and it's basically our map for turning a simple question into a real discovery.
You know, what's so great about this image is that it shows the process isn't just a straight line, it's a circle. The 5 steps are problem, plan, data, analysis, and conclusion. Each one flows right into the next, and sometimes that conclusion sends you right back to the beginning with a whole new problem. It's a really dynamic roadmap for any investigation.
So let's break it down really quick. First, you define your problem. Then, you plan how you're going to get the info you need. Next, you actually go out and collect the data. After that comes the really fun part, the analysis, where you start looking for the story. And finally, you draw a conclusion that answers that original question. Simple, right? We're going to follow this exact path.
Okay, so with our roadmap in hand, let's dive into the plan and data stages. I mean, before we can find any stories, we need the raw material. We need the data itself. But where does that stuff even come from?
Well, data basically comes in 2 main flavors. Think of it like cooking. Primary data is like you go into the farmer's market, picking out fresh ingredients yourself for a very specific recipe. You're collecting it through your own interviews or experiments. Secondary data, on the other hand, is kind of like using a pre-made sauce. It was made by someone else for a different reason, like a government report or financial data, but you can still use it for your meal. Both are super useful, but you really need to know which one you're working with.
And this brings us to a huge practical problem. If you want to know what, say, millions of people think about something, you can't possibly talk to every single one of them. It's just not possible. So what do? This is where statisticians have a very clever solution.
The solution is called sampling. It's like taste testing a giant pot of soup. You don't need to eat the whole thing to know if it needs more salt, right? You just take a good representative spoonful. That spoonful is your sample, and the whole pot is the population. If that sample is chosen well, it tells you everything you need to know about the whole pot.
And how you choose that spoonful is everything. You've got 2 main approaches. Probability sampling is the gold standard for being fair. Think of a big national poll that just randomly dials phone numbers. Every person has a known, fair chance of being included. Then there's non-probability sampling, which is all about convenience. This is like a YouTuber polling their own subscribers. Sure, it's fast and you get results, but it might not tell you how everyone feels, just how that one specific audience feels. It's that classic trade-off between scientific rigor and just getting it done.
All right, so we've got our problem, we've planned our attack, and we've gathered our data. Now we get to the really exciting part, the absolute heart of the PPDAC cycle, analysis. This is where the raw numbers stop being just a boring list and start telling a story.
Analysis really breaks down into 2 major branches. First, you've got descriptive statistics. This is all about summarizing what you've already found. It answers the question, what happened, by using charts and averages to tell the story of the data you actually collected. Then there's inferential statistics, which is more like being a detective. It takes that small sample we talked about and makes an educated guess about the entire population. It asks, what might happen? It's the difference between reporting on the past and predicting the future.
So the very first thing we usually do in an analysis is try to find the center of our data. We want to boil down a whole messy list of numbers into one single value that represents a typical data point. Where is the data's center of gravity?
And for that, we have 3 main tools. The mean is just the plain old average you learned about in school. Then there's the median, which is the number smack dab in the middle when you line everything up. This is perfect for something like house prices, where one billionaire's mega mansion won't totally skew the results for what a typical house costs. And finally, the mode is just the most popular choice, perfect for finding the most commonly sold t-shirt size. Each one tells you a slightly different story about where that center really is.
Okay, so we know where the center is. But that's really only half the story. I mean, knowing the average score on a test doesn't tell you if everyone got a similar grade or if half the class totally aced it and the other half failed miserably. Are the data points all huddled together, or are they scattered all over the place?
This idea is called dispersion. It's the measure of how spread out everything is. It tells us how consistent or how variable our data is. Low dispersion means all the data points are clustered really tightly together. High dispersion means they're all over the map.
And the single most important, most widely used measure for this spread is a value called the standard deviation. If you're going to remember just one term about how variable data can be, this is the one.
So here's the bottom line. A low standard deviation means your data is really consistent and predictable. Think of a basketball player who scores about 20 points every single game. A high standard deviation means the data is variable and unpredictable. That's a player who might score 40 points one night and then only 2 the next. They might have the same average score, but that standard deviation tells you who you can actually rely on. Okay, we've gone from a problem to data to analysis. And now we've arrived at the final C in PPDAC, the conclusion. This is the payoff. This is where all these concepts stop being theoretical and translate into real-world impact that helps us make much smarter decisions.
In this quote just nails why this is so important. Statistics isn't just some academic exercise. It's a barometer of economic activity. It's how we spot economic trends, it's how businesses decide where to invest their money, and it's how governments create policies that affect every single one of our lives. The numbers really matter.
So, let's bring it all home. Why does this stuff matter? Because statistics lets us condense a massive sea of data into a single understandable number. It lets us compare things fairly, like the performance of students across different schools. It guides our decisions when we're not sure what to do. And finally, it helps us establish relationships between things so we can try and predict what the future might look like. These functions are absolutely everywhere.
We live in a world that is just flooded with data. But now you have a framework, a way of thinking, and a basic set of tools to actually make sense of it all. So the question isn't whether the information is out there anymore. The real question is, what patterns are you going to uncover?